So we're asked to graph f of x equals negative 3x squared plus 12x minus 4 using transformations. Anytime we're given an equation in standard form, a quadratic in standard form, and we're asked to graph using transformations, that means we're going to need to complete the square and put it in vertex form. So in order to do that, let's factor out the negative 3 from the x squared and x terms first. So that's going to give us f of x equals negative 3. And again, just factoring it out from the x squared and x terms. Negative 3 times x squared. Now, we factored out a negative, so this positive plus x is going to become a minus. Negative 3 times negative 4 would be 12x, negative 4x. And we're still subtracting the 4 outside the parentheses. So now we'll go ahead and complete the square. We're looking at the coefficient on x, which inside the parentheses, which is negative 4. We'll call it b, so we want b divided by 2 squared. That equals negative 4 divided by 2 squared, which is negative 2 squared, which is 4. So we're going to add 4 inside the parentheses. So f of x equals negative 3 times x squared minus 4x plus 4. But now we're not just adding 4. We're still subtracting the 4 on the outside, but we're multiplying that 4 inside the parentheses by negative 3. So we're actually subtracting 12. So to counter that, we need to add 12 to the 4 that's outside the parentheses. Now we've completed the square, so we go ahead and simplify it further to that squared binomial. So it's going to be f of x equals negative 3 times x minus 2 squared, and then negative 4 plus 12 is 8. So to see exactly what we're doing here, let's look at each individual part. That negative 3, that means we're going to multiply each y value times negative 3. Let me make that x just a little bit bigger so I know it's a times and not a variable x. So that means we're going to multiply every y value by negative 3. The minus 2 inside the parentheses means we're going to shift 2 units to the right. And then the plus 8 means that we're going to shift 8 units up. So let's look at g of x equals x squared, our parent function. What points would we start with g of x equals x squared? So how about we start with, we can use any points that are on the curve that we're going to transform, but let's go with negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So for now, we're just going to apply that first part of the transformation, which is a vertical stretch. It's going to make it narrower, and we're multiplying it by 3. So for now, the x values are going to remain the same. We're not going to apply the horizontal shift as of yet. We'll do that in the next step. So for now, the x value is just going to remain the same. So that's going to be negative 2. And then we'll multiply the 4 by negative 3, which is going to give us negative 2, negative 12. Same thing with the next. X stays the same, negative 1, and then 1 times negative 3 is negative 3. 0, 0 stays the same. 1, negative 3, and 2, 4 times negative 3 is negative 12. And now we'll apply the next part of the transformation. That's the horizontal shift 2 units to the right. So negative 2 plus 2 is going to be 0, negative 12. Negative 1 plus 2 is going to be 1, negative 3, 0, 0. So 0 plus 2 is 2, 0. 1 plus 2 is 3, negative 3. 2 plus 2 is 4, negative 12. And then last but not least, we'll apply the vertical shift up 8 units. So 0, negative 4. Negative 12 plus 8 is negative 4. 1, negative 3 plus 8 is going to be 5. Forgot to put that negative in there. I said it, but I didn't write it. So 1, negative 3 will then shift up 8 units to 1, 5. 2, 0 is going to become 2, 8. 3, negative 3 is going to be 3, 5. And then 4, negative 12 is going to be 4, negative 4. Negative 12 plus 8 is negative 4. And now we can go ahead and plot those points. We know the vertex, it was originally 0, 0. Now it's going to be 2, 8. So our axis of symmetry is going to be x equals 2. So we'll go ahead and we'll plot 2, 8. We know it's opening down. We can just plot the rest of the points that we have. The 0, negative 4, 1, 5, 2, 8, 3, 5, and 4, negative 4. Now, after we plot all of these points, as always, it's just a matter of connecting the dots, indicating in behavior with arrows on the end of the curve, indicating that it goes on infinitely in the direction that we're showing on the graph. And there we have the graph of f of x equals negative 3x squared plus 12x minus 4 that we graphed using transformations by first completing the square to put it in vertex form and then applying the reflection and stretch, then the horizontal shift, and then lastly the vertical shift from points that we know are on the parent function, f of x equals x squared, or in this case we called it g of x equals x squared.